Okay, we have a private plane which is flying at an altitude of 235.4 above the CN Tower. The angle of depression to the top of CN Tower is 12 degrees. What is plane's horizontal distance from CN Tower? So go ahead, see if you can do this one. But remember, the first step is always to be able to draw the diagram for these word problems. Okay, as usual, the first thing we're going to do, we're going to draw the diagram representing the word problem. Very simple. I'm going to say if this is the CN Tower, the plane is here. So this line, which makes an angle with the horizon, is 12 degrees. Now, because of the TPTZ, if this angle is 12, this angle is 12. Now, what I have to do is to find this distance, the horizontal distance. Let's call it x. But we also know the altitude from the top of the CN Tower is 234. So this distance is 234. Now, since this angle is 90 degrees, we are talking about the right triangle, we can use the trig ratios. Now, the trig ratios, I know the angle, I know the opposite, which is this one, and I am looking for adjacent. So angle opposite adjacent is going to give me tan. So I can write tan 12 is equal to 234 divided by x. If I crisscross, remember this is denominator 1. If I crisscross, I'm going to get x tan 12 is equal to 234 divide by tan 12. And I'm going to get x is 34 divided by tan 12, which is going to be approximately how much?
1,100.
1,100?
0.88. 1,100.
0.88, right? Yes. So everybody okay? Okay, next question. You have two taxis, they leave Castlebrook Secondary School. One taxi heads at a speed of 36 kilometers per hour for 3.03 hours to its destination. The second one goes at an angle of 69 degrees away from the first taxi and travels at a speed of 37 kilometers per hour to its destination. Remember, they go the same amount of time, 3 hours and 03. How far apart are the taxis when they reach their destination? Just remember that the distance is speed times time. Okay? So go ahead, tell me how far apart are the taxis when they reach their destination. Now, to solve this one, again, I'm going to draw the diagram first. I know that the two taxis, they start from Castlebrook. Okay, so let's say they start from here. One goes this way, the other one goes this way. The only thing I know is that this angle is given to be 69 degrees. Also, the distance that they travel is known because I can find the distance by multiplying the speed times hours. So the first one is 36 kilometers per hour times 3.03. And how much is this one?
109.08.
109.08. So this side of the triangle is 109 and some change, okay, in kilometers. And the other one is going to be, let me see, 1 second, 37 times 3.03, which is going to be how much? 112.9? 11. Okay, so I know the other side, this one is 112.11 kilometers. Now the question is, what is this distance between them? This is the unknown, call it x. Okay, now I have two sides and the angle between, or the contained angle. So automatically you know that you have to use cosine law. So to use the cosine law, I write the equation regarding the side x. So I can write x squared is equal to 112.11 squared plus 109.08 squared minus 2 times 112.11 times 109.08 times the cos of the angle between them. Now, again, as usual, I'm not going to go through the computation by the calculator. What do you get with x squared here? What is x squared now?
125.23.
No, x squared, not the square root. 0.12. Okay, now to find x, I'm going to square root of both sides, so I get x is approximately 125.23.
Is this how the homework's going to be online?
Yeah. So we found that after 3 hours and 0.03, the distance between the taxis is about 125.23 kilometers. This is an example of a triangle which is not right triangle. So you can't use trig ratios here. You have to use cosine or sine law. Now we are going to repeat the same question, different numbers. Again, we have two taxis. They start from the same location. Let's say here, one goes to the right, the other one goes to the left. We know the angle between them is 62 degrees. Now, we are going to use the technique that Perner is using. Instead of using the distance, we are going to use the speed. So one goes with the speed of 30 kilometers per hour. The other one goes with the speed of 30 kilometers per hour. Okay, so both of them are the same. Now we have to find the distance between them. I have two sides and an angle between them, so I can use cosine law. So I can say if this is x, x squared is equal to 30 squared plus 30 squared minus 2 times 30 times 30 times the cos of the angle between them, which is 62. Now, again, I'm not going to do the computation. Can somebody tell me what is this 30 squared plus 30 squared and so forth? Did anybody get that one? 954? 0.9? 0.5, 0.9, so let's say 0.7. Okay? Now, to find x, I'm going to take the square root of both sides. So I'm going to get x is approximately how much? 30.9. Now, this is the speed, kilometers per hour. But I want the distance, so I'm going to multiply this 30.9 by 3.82. So I'm going to say x is really 30.9 times 3.82, which is going to be how much? 118.1. So the answer is 118.1 kilometers. Next question. You have an eagle which is being sighted between two observation points. From one observation point, the angle of elevation to eagle is 61.7 degrees. From the second observation point, which is 35.7 kilometers away from the first observation point, the angle of elevation is 43.8. What is the distance from each observation point to the eagle?
It's not right.
Okay? So you have to find the distance from the first and the second observation point to the eagle. Okay, so the first thing that we should do is to draw the diagram. We have an eagle and we have two stations. So let's say one station is here, one station is here, and the eagle is here. Now, we know that from one observation point, the angle of elevation is 61.7. So this means this angle is 61.7. From the second point, which is 35.7 kilometers away, okay, the angle of elevation is 43.8. So this angle is 43.8. The question is that what is the distance from each observation point to the eagle? This means that if I call this one A, B, C, I have to find AC and AB. This is the distance from the observation point to the eagle. Now, if I look at the information given in the diagram, it is obvious that I can't use cosine law because cosine law needs three angles or two sides and angle between them. I don't have either one of them. So my only hope is sine law, and you can see that I do have two angles and I can find the third angle using the rule that the sum has to be 180, and then I can go ahead and use sine law. So the first thing I'm going to do is that I'm going to say angle A is equal to 180 minus angle B, which is 61.7, minus angle C, which is 43.8. And what is the angle A? Can somebody tell me? 74.5. Okay, so this is angle A. Now, if we look at the diagram now I can see that I have an angle and a side in front of it, then I know that I can use sine law. So, to find, let's say, AC, I'm going to write AC over sine 61.7 is equal to angle A, which is, how much was 74.5? Yeah. So it's 35.7 divided by sine of 74.5. Okay? Now, if I crisscross here, I get AC sine 74.5, if I crisscross, is equal to 35.7 sine 61.7. Now I divide both sides by sine 74.5. This one goes with this one. So AC approximately becomes
32.6.
yes, 32.6 degrees. 32.6, sorry, meters. So this is this is side AC, 37.6. Now we are going to go and try to find side AB. Okay, now we are going to try to find AB. Again, I'm going to use sine law. I'm going to say AB divided by sine 43.8 is equal to 35.7 divided by sine of 74.15. Now again I use cross multiplication. I get AB sine 74.15 is equal to 35.7 sine 43.8. I divide by sine 74.15.
It's 74.5.
Yeah, 74.5.
74.5. It's going to be almost the same answer. So if you cancel 74.5 or 74.15, you get AB is going to be approximately
78.6.
78 point.
I got 78.6.
Whoa, that's a net. I got 25.6.
I'm never wrong. I'm never wrong.
So 25.6 meters.
No, I'm never wrong.
Even after this calculator,
Okay, the next question. You have two buildings which are 73 meters apart. The angle of elevation from the top of the shorter building to the taller building is 36, and the angle of depression to the base of the taller building is 57. You are supposed to find the height of the taller building. Okay, so the first step is to draw the diagram So we are going to have a short building, a tall building. The angle of elevation to the top building by the problem is given to be 36 degrees. And the angle of depression to the bottom is 57 degrees. If I call this triangle A, B, C, D, I have to find the side AD, which is the height of the taller one. So I'm going to use two right triangles, ABC and BCD, and I'm going to use the trig ratios. The only thing is that I know that BC is the distance between the two buildings is given to be 73. So I'm going to write tan 36 is equal to, in the upper triangle, is equal to AC over BC, which is 73. So from here, I get AC is 73 tan 36. And 73 tan 36 is going to give you 53.
Point nothing, it says point zero three, yeah.
Okay.
0.44, what?
Now, I'm going to use the lower triangle, and I'm going to try to find CD. So I'm going to say tan 57 is equal to CD over 73, and again, cross multiply, I get CD is equal to 73 tan 37. Now, this one is tan 57, and this is going to give you 112.4. Now, the height of the tall building is AD, which is AC, which is 53.44, plus 112.4, which is going to be
165.4.
165.4 meters.